Hey, what's up, everyone? We are live and ready to start talking about acids and bases. So all we're doing right now is waiting for people to show up, and once we get some questions, we'll start answering those questions. All right. So hold on. Sorry, I was seeing the delay from my own monitoring of the live stream. Hey, what's up, everybody? We got some people online. So how you guys doing? Got any questions? So we're doing some acids and bases. Instead of doing just going through all the targets, what I'm going to do is just kind of have it open for you guys to ask whatever questions that you want. So start typing them in. I'll see them right here on my computer, and we'll start going from there. All right. So just hanging out. So welcome, a couple of you that are just now joining us. As I mentioned, I'm just going to do a straight Q&A session here. Not really going to do anything specific because, I mean, last time when I was doing it, it just kind of dragged on for a really long time. So I just want to get right into what you guys need. So if you have any questions, go ahead and pull them up there. Hold on, let me check my settings here. Hold on. Hey, there's Hunter. What's up, man? What's going on? You guys have any questions? So we got a couple people watching. Any questions? Okay, so we got a question. How do we do neutralization reactions, and can you do an example? Yes, I most definitely can do an example of neutralization reactions. So I'm gonna head to my little marker board right here. All right, so for neutralization reactions, pretty much the question is gonna give you the reactants. It'll give you names, and so what you will have to do is write out the formulas from those names and then predict the products from there, okay? So I'm gonna come up with an example here. Let's say that we are dealing with sulfuric acid and how about potassium hydroxide. Okay, so sulfuric acid. Now this one shows up quite a bit, and you guys should memorize this particular formula. Sulfuric acid is H2SO4, and potassium hydroxide is KOH. K is potassium. OH is hydroxide. That's +1. That's -1. So they already add up to equal 0. So you don't really need any subscripts there. All right. Now, in a neutralization reaction, the first product is always good old water, H2O, and that comes from the hydrogen in the acid and the hydroxide in the base. Okay, so those two come together to make water. Then the other product is going to be whatever is left over after the water has been made. So in this case, we got sulfate and potassium. Okay, now potassium will go first because potassium is the positive ion. Positive ion always goes first. And then sulfate here will be next. Now we need to look at their charges. So potassium is +1, sulfate is -2, so we need 2 potassiums, K2SO4. And now that we have written out the full equation, now we need to balance it. Now there's a quick and easy way that we can balance these equations. Always start with the non-water product. So in this case, K2SO4. So I can see that I've got 2 potassiums here, only 1 here. So I'm going to put a 2 in front. I got 1 sulfate, 1 sulfate. So we're all good. Don't need to worry about that one. And then the only other thing that you have to do is look at the number of oxygens here in hydroxide. And in this case, we have 2. So that means we have 2 oxygens, and that is the number of waters that we have. Now, just to show you that that's how that works, we have 2 hydrogens right here, plus another 2 hydrogens there, so that makes 4 hydrogens. Well, 2 times 2 is 4, so everything there is balanced. Okay, so hopefully that gives you kind of a good idea of what's going on there. So what I'm going to do here is I'm going to give you another one, another example of this, and I want you guys to try and work it out on your own, and then I will put up the answer, and then we'll kind of compare, and we'll kind of see what's going on with that. Okay. So let's say that you are dealing with nitric acid, and let's say aluminum hydroxide. Okay, so nitric acid and aluminum hydroxide. Let's go ahead and try and write that out using the naming rules that we've gone through. Write out the formulas of those two, and then predict the products. All right. So I will start writing out my answer here. I'll try to cover it up as much as I can, and then we will go from there. All right. So you guys try that one out. All right. You guys ready? Hey, Fizz, what's up? All right, so you guys ready to check your answers? It's kind of awkward because I can't exactly hear you telling me if you're ready or not. So okay, all right, so it looks like most of you are just about ready. Okay, so here we go. So here is your answer. So nitric acid is HNO3. Aluminum hydroxide is AlOH3. Your first product is water. Then the second product is aluminum nitrate, AlNO3 in parentheses with a 3 on the outside. And then when you balance it, you have 3 of the nitric acids and then 3 waters. All right. That's how it works. So you guys are comfortable with that? Do you want another example? Want to try another one, or shall we move on to another concept? I'm gonna wait for you guys to tell me what you need. As I drink from my non-sponsored burger cup. There we go. Going over naming acids, and then can we do another one? Okay, so actually, since we can do naming acids and bases and do neutralization at the same time, let's do both, okay? So let me try and pull this up here. All right. So let's say we've got I'm gonna do something. All right, there we go. So hydrobromic acid, sorry, that's not written very well. That is hydrobromic acid. And let's do magnesium hydroxide. All right, so to explain the naming rules on this, okay, so since this starts with the prefix hydro, that means this is one of our binary acids, okay? Binary meaning 2, okay? So there's only going to be 2 elements in this one. Obviously, because it's an acid, the first element is going to be hydrogen. And then the other element, well, so this is bromic. And the IC is the INE, so instead of bromic, this is bromine, right? Br. Then you have to figure out how many or what subscripts you might possibly need. Well, hydrogen has a charge of +1. Bromine has a charge of -1. So you just add 1 and 1, and then that adds up to 0, so you don't need any subscripts. Okay, so plus. Magnesium hydroxide. Okay, so magnesium, the symbol is Mg. Hydroxide, the symbol is OH. Like so. Magnesium is in group 2, so it has a charge of +2. Hydroxide has a charge of -1, so we have +2 and -1, meaning hydroxide has to go in parentheses with a 2 on the outside of that. Okay, so that explains how you get that. So now what you guys need to do is attempt to figure out the products. Okay, so I've already given you the reactants to try and write out what the products are. Okay, so I'll give you about a minute or so to work that out on your own, and then I will go through it. All right, good luck. You are welcome, Hunter, and it's not Dan, by the way. I'm not wearing my shirt, but yeah, I still am not Dan. Never have been, actually. Not really sure why people ever call me Dan. It's a weird, long story. I'm not really going to go into it right now. Gotta tell you, it's really weird looking at the live stream of what you guys are seeing and how it's like 5 to 10 seconds behind what I'm doing. All right, so hopefully that is enough time for you guys to figure out what the products are. So let's do it. Okay, neutralization, first product is always H2O. The other product is going to be the combination of the other 2 ions left over. In this case, it is bromine and magnesium. Magnesium goes first because it is the positive ion. So Mg and then Br. And then we got to look up their charges. Once again, magnesium is in group 2, so it has a charge of +2. Bromine has a charge of -1. So +2, -1, meaning we need 2 bromines, so MgBr2. And now when we balance it, we're going to start with our non-water product. So I can say I've got one magnesium, so that's good. Two bromines, only one bromine there, so put a 2 in front. And now I'm going to look at the number of oxygens in hydroxide, and you can see that there are 2 oxygens. That is the number of waters that we have. And that completely balances this particular equation. Okay? And honestly, the more you do these, the more you realize it's literally the same thing over and over and over again. It's the same pattern, so there's not really anything new. So it really doesn't matter what type of equation I give you, you're going to do the same thing over and over again. What trips up most students when they're doing these, it's not the figuring out the products part. What trips them up the most are the ionic rules of looking up your charges and making sure that the charges add up to equal 0 to get the correct formula. So here's a little tip for you. If you are, when you get to the balancing part of this, after you've written out all your products and you're on to the balancing, if the balancing is ridiculously easy, meaning it's all ones, I would probably stop and make sure that you actually have the correct formulas for everything. Because like if it was just HBr, then MgOH, H2O, MgBr, and it's all ones, you've probably done something wrong somewhere. Also, if you are trying to balance it and it just will not balance no matter what you have tried to do, it's just too ridiculously complicated for you to try and balance, that's also a red flag that that you've got a wrong formula somewhere. Okay, so honestly, with all of these neutralization reactions, and especially with the ones that we're going to ask you to do on the test tomorrow, the balancing level is probably at that medium level. Okay, so if you got something that's just ridiculously easy, stop, go back, take a look at it just to make sure that you actually do have everything written out correctly. And then vice versa, if you're also spending like 5 to 10 minutes trying to balance it and it's just not working and it's driving you nuts, again, stop, go back, check your formulas, make sure that you've got the correct formulas, because we're not going to give you anything that difficult on the test. Because remember, what we are trying to assess on this test is not really your ionic abilities, which, I mean, yes, that's important, and yes, that's a part of, of chemistry. But the focus of this test is, do you know the acid and base stuff? There just happens to be ionic compound stuff kind of mixed into it. And so we're trying to assess your understanding of acids and bases, not necessarily your understanding of ionic compounds. So we're not going to give you anything ridiculously complicated to balance or formulas to write out. Okay? All right, so that is neutralization reactions. Do we have any requests for other stuff from the unit? Because remember, we got properties of acids and bases. We've got the definitions, Arrhenius and Bronsted-Lowry, acids and bases, the conjugate acid, conjugate base stuff. There's the strong versus weak. And then the big one, the pH calculations. So do you guys have any specifics? Okay, so we see, could you give us some little hints about what the free response is going to be of? Of course I can do that. Okay, so 4 questions on the free response, and it's hopefully pretty obvious as to what is going to be on the free response. So there's obviously one of these, a neutralization reaction, and it'll be more like this. So I'm not going to give you any formulas. We're going to give you the names. You have to write out the formulas, write out the products, and then balance it. Okay, it's obvious that that's going to be one of your questions on the free response. Also, there's going to be a pH chart where very similar to what you've seen on the all the daily work stuff we've been doing. But basically, let me kind of sketch out. Okay, I know this is ridiculously bad here, but like I will give you a pH, and then you have to find the OH and the hydrogen concentration, hydroxide concentration, and then is it an acid or base? Okay, so we'll give you one of these four values, and then you'll have to find the other three. And then at the end of it, you will have to find the acid or base. Okay, so there's something like that. So we got neutralization, we got pH calculations. Also on the free response, we're going to give you a Bronsted-Lowry equation where you have to identify what's the acid, what's the base, what's the conjugate acid, and what's the conjugate base. Okay. And then finally, the fourth question on there is a description of a substance where you have to identify it as a strong acid, strong base, or weak base. If you remember the very last question on the online quiz that we did earlier this week, there's a little, the video question where I dipped in the litmus paper and I showed it to you guys, and it was like, okay, is that acid or base? And then we did the conductivity test. Something like that. Obviously, except I can't do the, it's not an actual video, but it will be a description. And then you say strong acid, strong base, weak base. Okay. Let's see. How do you do the pH calculations? Okay. So yeah, let's do that. That is a great question. So let me pull this up a little more. Okay. So pH calculations. It seems somewhat difficult when you first look at it, but ultimately what it comes down to is, do you know how to use your calculator and know the process of what you're trying to do? Okay. So let's say you're given either one of these concentrations, so either the hydrogen concentration or the hydroxide concentration. These are going to be numbers in scientific notation. Okay, so I'm just going to come up with one right off the top of my head. Let's say we have 2.5 times 10 to the -6, right? And this is the hydrogen concentration. Okay, if we are trying to find the pH, now I know it's going to be pH because it's the H. If this was OH, then this would actually be POH. Okay, so the ions have to match up. Okay, so what I'm gonna do here is, first, before I actually calculate it out, I'm going to write out literally what I'm gonna type into the calculator, and then we'll give you the answer. Okay, so here's where you have to know how your calculator works. There are some calculators that require you to type log first, and then you type the number, and then there are some calculators where you type in the number and then you hit the log button. So it just kind of depends on how your particular calculator works. So I'll write out basically both ways. Okay, so if you have a calculator that requires you to type in the log first, then what you hit is the log button on your calculator, and then you type in this number. You'll type in 2.5, you hit the EE button, right, and then -6. And then you hit equals. You will end up with a negative number. So make it positive, because obviously pH has to be a positive number. Okay. Now, let's flip it around the other way. Let's say your calculator works differently. So in that case, what you're going to do is you're going to type in 2.5 EE -6. Then you hit the log button. Then make it positive. Okay. So in this specific example right here, okay, I'm gonna grab my calculator right here. So for mine, I have to hit log first. So I'm gonna do log of 2.5. Uh-oh. Come on, go away. Uh-oh. Sorry, this is really awkward. My Kindle is showing an ad directly above the button I need to be pushing. That's ridiculously awkward. Okay, let's try that again. There we go. All right, so log of 2.5 EE negative 6. And I'm going to hit equals. And so what I get on my screen is a negative 5.6. So here, the pH, since I'm going to make it positive, is 5.6. Okay, so that's what you do. Wait. So for hydrogen, we don't put it. Well, okay. There are a lot of different ways. So Mackenzie, to answer your question, there are about 1 billion different ways that you can do this. It really just kind of depends on your preference. Okay, the official formula here is pH equals the negative log of the concentration. Okay, so yeah, if you really want to, you can type in negative log of 2.5 times 10 to the negative 6, hit equals, you don't have to worry about that. For some reason, that's just not how my brain works. I don't know. So that's why I do it like this. But yes, if it makes more sense for you to type negative log and then that, by all means do that. There's nothing wrong with it. We're still going to end up with the exact same answer. Okay, as long as you end up with 5.6 doing it your way, then it really doesn't matter. Okay, so hopefully that answers that question. All right, so let's flip it around the other way. Let's say you're starting with the pH or the pOH and you need to find the relative concentration. Okay, so let me set down my calculator here. Bring this up a little more. Okay, let's say that we have a pH of, I don't know, 12.6. We have a pH of 12.6, and we want to find the relative hydrogen concentration. All right, well, you're going to do the exact opposite process of what you did up here. So instead of using the log, we use the anti-log. Now, on most calculators, the anti-log is the second function of the log button. Like when you look at the log button on there, there's in like smaller letters above it, it says 10 to the x. That's the anti-log. Okay, so we're going to use that. Now, remember, since we had to make it positive here, we're going to literally do the exact opposite. And so what I'm going to do is first, like in this case, I'm going to make it a negative 12.6, okay, because it has to be a negative number in order for this process to work, okay? So, excuse me, I'm still trying to get over a cold. All right, so I'm going to have a negative 12.6, and then depending on how your calculator works, so let's say you have one of the calculators that requires you to type in the function first. So what you're going to type in actually is second log. And so on your screen, what you'll see is 10 to the, and then your little cursor will be waiting for you. Then you do negative 12.6. Or if your calculator requires you to type in the number first, then what you're going to do is negative 12.6 and then type second log. Okay, so if you will do that one with me. Oh, is there something going on with the stream? Uh-oh. Let me check what's going on my end. See if it's yeah, on my end, it's saying that the stream is okay. Yeah, so really, anytime you run into an issue there, yeah, just go ahead and hit refresh. and that should take care of that problem for you. All right. So sorry about that. I hope it works. Hope it works for you. All right. So we're going to try this one out. All right. So since my calculator requires the function first, I'm going to do second log, and then I'm going to type in negative 12.6. I'm going to hit equals, and then what I see on my screen is 2.51189, blah, 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 blah. So just for the sake of ease, I'm going to round this to 2.5 times 10 to the negative 13th power. All right. So there you go. Hopefully that makes sense. Okay. And obviously I can do a whole lot more examples on that if necessary. But before we do more examples, what I'm going to remind you is that then the connection between pH and pOH, right? So pH plus pOH equals 14. Okay, so all you got to do is you take 14 minus whatever number you have, and then that will give you the other one. Okay, so without further ado, let's do some practice. Okay, so I'm going to make a little chart here. So we got pH, we got pOH, hydrogen concentration, hydroxide concentration, and then acid or base. And I'm going to start with a pH of 8.2. Okay, so we have a pH of 8.2. Find everything else. All right, let's see what we can do. I'm going to give you guys a couple minutes. I'll try to cover this up as best I can. I'm going to write out my answers, and then we will compare. And hopefully that'll be good. All right, so you guys try it out. What's 8.2? 8.2 is the pH. Oh, look at that. We've got some trolls. Oh, whoops. I'm just only letting the answers hang out there. All right, trolls. Goodbye. All right, took care of them. Not too difficult. Okay, so hopefully you guys have had a chance to work that out. So with a pH of 8.2, we do 14 minus 8.2, and we get 5.8. All right, it's all good. Yeah. So G, Yeezy, yeah, we'll get to that as soon as we're done explaining this. All right, so 14 minus 8.2 gives us 5.8. And then what I'm going to do is I'm going to take negative 8.2 and do the second log, and that gives you 6.3 times 10 to the negative 9. Don't worry so much about rounding. Round to whatever it is that you're comfortable with. It's not that big a deal on this one. And then for the hydroxide concentration, I'm going to take the POH. So I'm going to take a negative 5.8 second log to get that. And then for the acid or base, what I'm looking at is the pH. Remember, 0 to 7 is an acid, and then 7 to 14 is a base. So there you go. Okay. Now, before we move on to the conjugate acid, conjugate base stuff, I really want to do one more example of this to kind of make sure that you guys really kind of have a good idea of how you're doing with this. Okay. So so this time what we're going to do is I'm going to give you the hydroxide concentration. Let's say we have a hydroxide concentration of 6.7 times 10 to the negative 4th power. Okay, so that's 6.7 times 10 to the negative 4th power. Try to calculate all the rest of that and then see what you guys can do with it. Okay, and then we will move on to conjugate acid, conjugate base. All right, so good luck. Try to figure that out, and then we will move on. Sorry, Kyle, I actually don't have a Snapchat, so not going to happen. As much as I would love to. No offense or anything, but yeah, I don't have a Snapchat. Okay. All right. Sorry, I'm reading some of the comments. I got my monitor screen down here on my feet. All right, so let's check our answers here. All right, so since we had 6.7 times 10 to the negative 4th for the hydroxide concentration, we're going to type that in, take the log of that, and make it positive, and that gives you a pOH of 3.2. You may have also had like a 3.17 or whatever that, so don't worry about the rounding on this. However, before we go any further, I do want to point out that if you rounded differently than I did, then your other numbers aren't going to be exactly like mine, so don't worry too much about that. As long as you were following the same process, then you're still going to get it right. Okay, so I got 3.2 for the POH. Now, some of you might ask, well, how do I know that that's POH and not pH? Well, very simple, because this is the hydroxide concentration. OH, OH. The ions have to match up. Okay, so that gives me 3.2 there. So I'm going to do 14 minus that to get 10.8 for the pH. And then I'm going to take a negative 10.8 and do the second log to come over here to get the hydrogen concentration. So what I got was 1.58 times 10 to the negative 11. And then for the acid or base, well, I took a look over here at the pH. I got 10.8. Well, that's in the 7 to 14 range. So obviously that's going to be a base. Okay. Hopefully that's there. Yay, more trolls. Around here we have a phrase for all you trolls. It goes, deleted. So there you go. And goodbye. All right, so let's see. We had a couple other questions over here. Along with that, can you explain how to get the other non-water product? Okay, so Ellie, if we have chance at the end, or if there's time at the end, I'll go do that because I've already done that. So actually what you could do is even just rewind this stream until you go back to the beginning, because I talked about all that at the beginning there. Okay. All right. We got more trolls. Yay. All right. Hey guys, don't worry about people who are getting on and saying ridiculously offensive stuff. They're just trying to get a rise out of you. Don't worry about it. I'm watching. They're getting kicked out as soon as I see it. Okay. Like that one. All right. So Brendan's asking, can we do one more example with the chart? Okay. We will do one more example of the pH calculations, and then we will move on to the conjugate acid, conjugate base stuff. Okay. All right. So here we go. This time I'm going to give you the hydrogen concentration here. And let's say that you have a 2.4 times 10 to the negative third power over here. Okay. Oh my goodness. All right. All right, so if the pH is from 7 to 14, that is base. Yes, that is correct. 7 to 14 is base, and 0 to 7 is the acid. All right, so going back to this. All right, so if this is what we're starting with, our hydrogen concentration, in order to find the pH, then we're going to type this number into the calculator, you hit the log button, and you make it positive. Okay, so I'll grab my calculator here. And so I've got the log of 2.4 times 10 to the negative 3. That gives me a negative 2.6. So I'm going to make that a positive 2.6. That's a pH. Positive 2.6. And now that I have my pH, what I can do is 14 minus 2.6. All right, so 14 minus 2.6, and that equals 11.4. That's my POH. And now to go back to the hydroxide concentration, I'm simply going to make this a negative number and then do the second log of that. Okay, so I'm going to do the second log of negative 11.4. And what we get is 3.98 times 10 to the negative 12 power. Okay, and then for the acid or base, I'm going to look at the pH. Since this is between 0 and 7, this is an acid. Okay. All right. Okay. How are you supposed to know that, though? By the formula H2O. Okay, so some of you are asking questions about how water is an acid or a base. Well, that actually has to do with the definitions. So the Arrhenius definition says anything that starts with a hydrogen is an acid. So obviously H2O starts with an H, so it's an acid. The Arrhenius base definition says it's an OH, then it's going to be a base. Well, water is exactly HOH. You're welcome, Brendan. HOH, so it's got a hydrogen, it's got a hydroxide, so therefore it's an acid and a base. According to the Bronsted-Lowry definition, anything that gives up a hydrogen is an acid. Well, water has the ability to give up a hydrogen to become OH, so it's an acid. And then it also has the ability to gain a hydrogen because the Bronsted-Lowry base definition says if it gains a hydrogen, then it becomes a base. Okay, so yeah, water is a very strange substance. Okay, so it's both acid and a base. All right, so there was a request earlier to do the conjugate acid, conjugate base stuff. So let's move on to that. All right. So as I was just mentioning, the Bronsted-Lowry definition says an acid is anything that gives up a hydrogen, and the base is anything that receives a hydrogen. Okay. So let's say we have something like NH3 plus H2O. And then on the other side, we have OH minus plus NH4 plus, like that. All right. So if we are taking a look at this equation right here, so what I'm going to do is I'm going to see, all right, so NH3 becomes NH4 over here, which means that we are gaining a hydrogen, making NH3 the base. H2O gives up a hydrogen to become OH, therefore this is the acid. And then when we go the other direction, we can see that OH to become H2O has to receive a hydrogen. So that would be a base, but because it's on the right side of the equation, it's the conjugate base. And then the NH4 going this direction gives up a hydrogen to become NH3, making this the conjugate acid. Okay, so a couple things to remember with these particular equations. One, the acid and base can only be on the left side of the equation. Okay, nowhere else. It's going to be either one of those two places. That means that the conjugate acid, conjugate base is only over here on the right-hand side of the equation. Okay, so it very much narrows down kind of your guessing on that. Plus, there are a couple different ways you can kind of remember how everything kind of matches up here. One, you could just flat out memorize that the acid will always pair up with the conjugate base, and the base will always pair up with the conjugate acid, or you just read the equation right to left, and then you can figure out what's the acid and what's the base based on the Bronsted-Lowry definition. Okay, so do I play CS? Sorry, no. I'm more of an RPG player. I don't really get into the warfare type games. All right, we got another question. Isn't there an intermediate step where the H-OH ions dissociate? Yeah, yes, technically, but for the level of what we're doing in this class, that's not really a step that we have to do. So if you really want to, you can, but yeah, it's not really necessary. Okay. Play WoW? Not really. We can discuss my gaming interest in full detail a little bit later on, but let's focus on what we're trying to do here. Okay. All right. Oh, this is for on-level chemistry. So what you were describing is more of an honors and AP kind of concept. So yeah, this is, I'm really just kind of focusing on the basic the on-level concepts. Okay. All right. So sorry, I had a little brain freeze right there. All right, so let me give you another example here, and then I'll kind of explain in more detail what exactly the conjugate acid and conjugate base and all that good stuff is. Okay, so this time, let's say we have say HNO3 and yeah, sure, for grins, let's do another H2O. And on the other side, we're going to end up with NO3 and H3O. All right. So here we go. HNO3 becomes NO3. It is giving up the hydrogen. Okay, so this gives up the hydrogen. Therefore, there's your acid. The H2O gains the hydrogen to become H3O, making this the base. Okay, now when we go the other direction, NO3 gains a hydrogen to become HNO3, making this the conjugate base, right? And then the H3O is the one donating hydrogen, it's giving up the hydrogen to become H2O, so this is the conjugate acid, okay? So the conjugate, so to kind of sort of try to answer your question earlier about what is the conjugate acid and what is the conjugate base, well, the conjugate acid is the substance on the right side of the equation that matches up with the base. The conjugate base is the substance on the right side of the equation, or the product side, that pairs up with the conjugate acid. Okay, I mean it's really not as difficult a concept as a lot of people try to make it, because they go into all this detail about, you know, looking at the equation and, oh, really it's at equilibrium, so it goes both ways, and you know, and I find that it's just way simpler just to take a look at what's giving up the hydrogen and what's receiving the hydrogen, because ultimately that's the Bronsted-Lowry definition. According to Bronsted-Lowry, an acid is anything that gives up a hydrogen, and a base is anything that receives a hydrogen. I mean, it's really that simple. Okay. So without further ado, how about I give you guys a couple more examples, because I mean these are really fast. So I will write out 2 more equations. I'm going to have you guys try to figure out what they are, and then we'll go over the answers. Okay. All right. So here we go. Let's say we have H2CO3 plus OH minus, which on the other side will give us, hold on, CO3 with a charge of -2. No, I'm sorry. Wow, I clearly did not think this one through. Hold on, let me try that again. It's going to be HCO3, the charge of -1, plus H2O. Okay, so there's one. And then one more example. Let's say we have H2O plus HSO4, which then gives us OH plus H2SO4. All right. You may man, Le Chatelier. Yes. Fun name to say. All right, so go ahead and try to identify what is the acid, what is the base, and what is the conjugate acid, and what is the conjugate base. So I'm going to give you guys about a minute, and then I'm going to write it out myself. And while you are doing that, I will mention that my favorite game right now is actually kind of up for grabs. For the longest time, I would say that my favorite game was the original Fable, like that was for the original Xbox. Absolutely loved Fable. But right now, I am really into a game called Kingdoms of Amalur Reckoning, which is kind of obviously inspired by Fable, but the combat in the game is so amazingly awesome. I think I'm a little obsessed with the game right now. But yeah, I don't exactly get to play as much, I guess, really as I like. I mean, let's face it, I'm a husband and I'm a dad. I've got 2 kids, so yeah, Skyrim's pretty cool. I've not had a chance to actually play it myself, just because, I mean, games are kind of expensive, so really the only games I have are the ones that people give me. But yeah, Kingdoms of Amalur, it's totally rocking my world. I'm actually on my 4th time through playing the game now. Like I said, I'm a little obsessed. All right, so back to chemistry. All right. So here we go. So H2O or H2CO3 becomes HCO3, so it's the one giving up the hydrogen. So this is the acid, and then since that's the acid, that means this one is the conjugate base. OH gains a hydrogen to become H2O. So because it gains a hydrogen, that's the base, and this is the conjugate acid. And then to kind of explain that going the other direction, so HCO3 is the one gaining the hydrogen that way, so that's why it's a base, and then the H2O is the one giving up a hydrogen over here. That's why that is the conjugate acid. And then down here, so H2O is becoming OH, so it's the one giving up the hydrogen, making that the acid. HSO4 is gaining a hydrogen, so that makes this the base. Going the other direction, OH gains a hydrogen to become H2O, so that's the conjugate base. H2SO4 gives up a hydrogen, conjugate acid. All right. Yes, you are exactly right, talking about non-chemistry stuff. Okay. All right. We got another troll. Around here, we got a phrase we like to tell you. So, Mr. Sanpai AJ, goodbye. All right. Okay. Oh, looks like we got another troll, so we'll say goodbye to you too. All right. And so there we go. All right. So that's conjugate acid, conjugate base, Bronsted-Lowry stuff. All right. So I believe we pretty much covered just about everything. So, and we've also been going for about an hour now. So I'm going to wrap it up real quick. Nice Legos, yes, thank you. I'm a huge Lego aficionado. Maybe I'll do a video on that sometime. Yeah, I'll do like a special video, just kind of going through all the cool stuff here I got in my room. I think that'll be fun. Anyway, so let's wrap up. Just remember your properties of acids and bases. So acids taste sour, feel sticky. Bases taste bitter, feel slippery. Acids obviously produce hydrogen ions. Bases produce hydroxide ions. For the litmus paper test, acids turn litmus paper red or pink. Bases turn litmus paper blue or purple. They are both electrically conductive. Acids are the ones that are corrosive to metals. Bases don't react with metals at all. However, they both do. Sorry, I'm getting distracted by all the comments over here. They both do react to human tissue. On the pH scale, acids are 0 to 7, bases are 7 to 14. And then when it comes to the strong versus weak stuff, which based on a lot of you guys, your responses on the quiz that we did earlier this week, you guys know this, the strong versus weak stuff. It really has to do with ionizing. So if it completely ionizes, that is strong. If it only partially ionizes, that is weak. And you can translate that into the electrical conductivity. So if it's a bright shining light, obviously very conductive, complete ionization, so it's strong. Barely lighting it is going to be more of the weak stuff. Okay. All right. And so yeah, that Millennium Falcon up there, yeah, that is the hard to find one. That's not the new one. That's the older one. Yeah, I'm that one took me 13 days to make. Yeah, it was a lot of fun to put that one together. So, and in 10man01, yes, there will be free response questions. If you kind of scroll back to, I don't know, somewhere in the 5 to 15 minute mark of this live stream, I went over all that stuff. So there you go. I would love to stay and chat with you guys some more, but it's kind of late. I need my beauty sleep. I mean, you can tell I'm getting uglier as the night goes on, so I need to go. So thank you guys so much for logging in and answering questions, especially for those of you that are joining us that aren't in any of my classes. You guys are awesome. Thank you guys for showing up. Love you guys so much. You guys rock, and you know I'm always here to help out. So we will chat again. So I will give you my signature line. Remember, I'm not Dan, and neither are you. All right. Check you guys later.